Hello, chemistry fans, and welcome yourself back to Chemistry 1032 problem solving session here at the Academic Success Center on Broward College North Campus. I am your host, Dr. Russell Betts, and I'll be guiding you through this problem today. So without any further ado, let's take a look at this problem. Chapter 10, Problem 7. What is the pH of a solution that has a concentration of hydronium equal to 3.4 times 10 to the negative 2? It's a very common question. It's a pH question. pH equals the negative log of the concentration of H3O plus. It's a very simple question if you just look at the formula or the expression or the definition, if you will, of pH. Now, let's talk a little bit about pH before we get into this calculation. pH is a scale that typically goes from 1 or 0 to 14. That's typically where it is. It can be a little bit less than 1 or 0, but for this class we usually stay within 1 and 14. pH of 7 is considered neutral. At neutral pH, the concentration of hydronium equals the concentration of hydroxide. That's neutral, pH of 7. Anything below pH 7, say pH 6, is considered acidic. Even 6.9 is acidic. Anything above pH 7, say 7.1, is basic. Now 7.1 is slightly basic. Things like pH 12 are very basic. Okay? So below pH 7, you're acidic. Above pH 7, you're basic. Now, let's look at this question here. What is the pH of a solution that has a concentration of hydronium equal to 3.4 times 10 to the negative 2? Well, very, very simple. All you got to do is plug the number into the expression. Okay? Now, for those of you who may not be familiar with this symbolism here, the square brackets around a molecule or an ion, that means concentration of in molarity. So the concentration of hydronium in molarity. I could have put anything in between the brackets. It doesn't have to be hydronium, but in this case it is. So this means concentration of hydronium in molarity. Okay? That's what that square bracket tells us. So now, this becomes a calculator question. Now the biggest problem, or one of the bigger problems, with 1032 is not everybody has the same calculator. And not everybody's calculator works the same. So, what I'm going to show you on this calculator may not work on your calculator. Different manufacturers and different models inside the same manufacturer work differently. So you have to figure out how to do it on your calculator. If you don't know how to do it or you can't do it, contact one of the tutors here at the Academic Success Center. They will help you figure it out. But the last thing you want to do is approach this question on an exam. And for my class, it will probably be there. You don't want that to be the first time you're trying to solve this problem, because you may not be able to do it because your calculator may not be as clear-cut as it should be. So make sure you can do these before you hit the exam. All right, on this particular brand, you would hit negative, find the log button, hit log, 3.4. Now, on this one, you hit second function to get the EE expression, E, negative 2 close brackets, or parentheses, equal 1.4685, yada, yada, yada. So the answer here would be 1.47. Now, that might be a little strange to you. You might be like, wait a minute now. Here we have 2 significant figures, and here you have 3. Well, for pH, or for any log really, any log system, but we're dealing with pH, the digits in front of the decimal point are not counted in the significant figure counting. It's only the digits after the decimal. So here we have 2 significant figures, so we have 2 decimal points. That's how you do it. The first numbers in front of the decimal point, they don't count towards being significant. Only the ones after are the significant digits. So here we have what appears to be 3 significant figures, but really it's only the digits after the decimal that you consider to be significant. The ones in front are they're giving magnitude. Okay? So 2 significant figures, 2 decimal points. If I had had 4 significant figures here, I would have had 4 decimal points here. Okay? So don't forget that. The number of significant figures up here is the number of decimal points down here when doing logarithms. And the only time we do logarithms in 1032 is right here, pH. Okay? So again, this looks like 3 significant figures, but it's not. It's only 2 because it's in a log scale. Okay? The significant figures in the expression are equal to the decimal points in the answer. So 2 sig figs, 2 decimal points. All right? That's the hardest thing about pH calculations, is remembering that. Okay? Now, without any further ado, I hope that you guys found this video helpful, and I hope that you can easily solve pH questions. If not, don't hesitate to contact one of the tutors here at the Academic Success Center. Get this straightened out. Get your calculator straightened out. Don't let that sit down. Don't let that screw you up on an exam, especially. If you're having any difficulty, come and find a tutor here at the Academic Success Center. Or if you want, come on by my office during office hours, or your own professor during office hours, and get this stuff straightened out. It's not hard. Easy points on an exam. All right, guys? And with that, I'd like to wish you good luck and good chemistry.